Hello everyone, my name is Hemu. In today's, it's a day 2 of our AWS training. In today's class, we are going to discuss. So I will go through with the introduction of AWS, history of AWS, how AWS is started, all these things. Then we will go through with the most important thing, which is global infrastructure of AWS, means how AWS have a global presence, where we will discuss what is region, what is availability zones, what is local zones, what is edge location, what is point of presence or pop locations, what is outpost, what is wavelength zone, right? So all these particular topic comes under the global infrastructure. Once this part will complete, I will tell you how we can basically choose a region. We will discuss what is region, then we will, because AWS has multiple regions across the globe, then we have to decide which region we have to choose and why we have to choose, right? So we will see which region we have to choose and what are the parameters we have to consider. Then we will discuss. I'll just give you some very basic overview of AWS services, where we will see what is the AWS global services and what are the AWS region specific service. Then I will, again, once this part will complete, I will move towards the on-prem network. What are the things we have in the on-prem? How the traffic flow in the on-prem network component versus the AWS networking components. I will also explain you the ways to access the AWS resources, means how we can access the AWS resources. What is AWS Management Console, AWS CLI, and AWS SDK, or which includes the API and programs, which is totally like in automation, we will use all these things. Okay. Then I will just give you the basic idea about the AWS networking services, like what is BPC, what is Elastic Load Balancer, Direct Connect, Route 53, CloudFront, AWS WAF, AWS Shield, and AWS Guard Duty. These are the some of the services I have mentioned. I'll just give you the basic overview. In these particular services, we have a lots of sessions. Like let's take an example, Route 53. In Route 50 I needed around 4 classes, which means around 12 hours I need to explain everything in Route 53 along with the practicals. Okay, so don't worry, today I'll just give you the basic idea about it, and once we will basically, when we will move further in this syllabus, we will discuss everything in detail. Okay, like in load balancer, there is a 4 to 5 classes are there for the load balancers. Okay, there are multiple use cases in load balancers. Okay, so these are the topic which I'm going to cover. So now let me start with the AWS cloud integration. Okay, so first of all, before explaining anything, let me just tell you. So guys, if I will write down some of the cloud service providers, some names of the cloud service providers, the very first cloud provider is AWS. Then we have a Microsoft Azure. Then we have a Google Cloud, which is GCP, Google Cloud Platforms. Then we have a IBM. We have a Oracle. We have a Alibaba. And there's a multi like DigitalOcean, Rackspace. There are lots of other vendors are there as well. Okay. Now, this particular AWS company, AWS stand for Amazon Web Services, means this particular cloud is owned and managed by the Amazon. Azure is a cloud which is owned and managed by the Microsoft. GCP is managed by the Google Cloud. Then we have IBM, Oracle, and Alibaba. Now, guys, according to the Gartner report, AWS is the #1 cloud. Means it is the market leader in your cloud service provider. Means there is a lots of customers who is using the AWS, and the best why they are using AWS, because AWS focuses towards the infrastructure as a security, infrastructure as a infrastructure as a security, and this particular Azure, they are basically platform as a service. The business model for Azure is, sorry, it says software as a service. So Azure is more focused towards the SaaS services, and AWS is focusing towards the infrastructure as a service, means IaaS. Okay. So the business model for AWS is infrastructure as a service, means most of the customers, they will choose this AWS because of the infrastructure as a service. Okay. Now, AWS, like Amazon Web Services, is the world most comprehensive and broadly adopted cloud platforms. It is offering over 200 fully featured services, means AWS has more than 200 plus services, and you can able to check all these services here. See, we have a long list of the services. Click on all service and you can able to see these are the multiple services which are offered by the AWS environment. Okay, and if you will go into the Google and if you will type AWS Gartner Magic Quadrant 2023 images, let me open this. If you will see this one, this is also not the correct one. Mm, let me just see. I have one of the slide for that. Okay, let me just open it. Give me 1 second. Sorry guys, it is infrastructure as a it is infrastructure as a service, not security. Okay, 1 minute. I'm just opening one PPT. Just give me a second. Okay, so where I have one slide for this Magic Quadrant. Okay, if you will see this particular Magic Quadrant, in this Magic Quadrant, so generally what used to happen, there's a one company called Gartner. What they used to do, they used to done lots of R&D on the services offered by different cloud vendors, right? And according to the output from the different customers, what they used to basically create this particular quadrant, right? So if you will see in the leader section, we have a Amazon at the top. Okay, so AWS has a huge customer base, and after that we have a Microsoft, then we have a Google. So these are the three which which are in the leader quadrant. So these are the market leaders. So most of the market share is owned by the AWS, then Microsoft, then Google, and after that we have a Alibaba and Oracle. Then we do have a IBM, Huawei, Tencent Cloud, right? The others one. Okay, so these are the, this is the one which I wanted to show you. So why we have picked this AWS? Because AWS is the leader in the cloud service providers domain. So that is the reason we are here to learning the AWS. Okay, now so generally what AWS has a millions of customers, which includes the fastest growing startups. Means, see guys, these cloud environment is very good for the startups organization, and I have explained the in depth, right? What is the main reason why a startups generally use for the, why this startups choose the cloud providers for launching their resources, right? Because they don't need to pay any upfront cost, right? Even though they also have a very big, large enterprise customers, leading government agencies. So, guys, what AWS has done, AWS has created a dedicated cloud environment for governments, actually, where government-related things are there. Means, let's suppose in USA they have created one government-related region where only government people can able to launch their resources. Like you, me, we are not allowed to use these clouds. Okay, these clouds is dedicated for the government only. Using AWS to the lower cost, become more agile and innovate the faster things. Okay, the AWS global infrastructure is the most secure, extensive, and reliable cloud platforms, offering over 200 fully featured services from data center globally. Whether you need to deploy our application workload across the globe in a single click, or you want to build or deploy specific application closer to your end users with the single digit millisecond latency. Means, see what happens basically, AWS has a lots of regions across the globe, right? And they have a very all these regions, they have a connectivity through the very high speed fiber links basically. So you will not face any type of latency. Okay, AWS is a set of cloud computing services. AWS is robust, scalable, and affordable infrastructure for the cloud computing. AWS provide compute, storage, and data services quickly, provisioning the IT needs. Means, let's suppose a company A wants whatever networking infrastructure this company A needed, everything they will found over the AWS environment, because AWS has lots of services. Okay, the main benefit of AWS is, it is AWS, the main benefit which is like security. So whatever resources you will deploy over the AWS, they are secure. Availability, because AWS has a global presence. So because these particular resources are highly available, you will get the performance, because the AWS generally uses the high end or always the next generation devices or hardware components. So they will have a very good performance. Scalability, you can use the features like auto scaling type of things, so you will get the scalability type of things as well. Flexibility, very easy to use, very user friendly GUI they are having to basically launch your resources, so it's very flexible. Global footprint means they have a availability across the globe. Okay, it's not like that, like they have a presence over just on one country and all, right? So they have a global presence across the globe. Service level agreement, they have a very good SLA. They have a SLA between 99.9% to 100% availability. Means they used to say whatever resources you will deploy over the cloud environment, it is available 99.9%. Okay, Amazon S3 maintains a durability of 99.5 times 9%. Means they have a SLA of very high availability related things. Okay, means their resources is always available. They will give you the 24 by 7 support. Flexible cost optimization, they have a very good pricing model. You can go with the pay as you go model, right? You can also choose the resources on the basis of term based plan. You can purchase like for 1 year, 3 year, 5 year, right? Broadest and deepest platforms, user friendly, highly performant. Means they whatever resources they are having, they have a very high performance and all, right? These are the couple of URLs I have shared here. So you guys just needs to go and you have to just check the information. Okay, because maybe sometime in some of the links you will found more benefits. There are some less benefits, right? But if you know couple of them, which is good, basically, that's it. And if you want to check AWS, this is the link for Gartner, which we have already seen. But let me just open this particular link. So this is the link where you can check AWS at the top. So it's a market leader. Then second is Azure. Then we have a GCP. And guys, GCP is very growing a lot. Okay. I know around 4 years back, AWS has captured around 70% market. Okay. And there was around 20% market is captured by the Azure, and the remaining 10% market is for the other providers like we have a GCP, Alibaba, and all. But nowadays, Azure and GCP, they are also growing a lot. Okay. Just remember. Now let's just go through with some history of the AWS. Okay. So Amazon Web Service is a cloud computing platform that was launched by Amazon in 2006. Means AWS started in 2006, guys. Okay. In year 2002, AWS services were launched. Means in 2002, generally they have launched couple of services, and in 2006, officially AWS cloud products were launched, and AWS was officially launched in 2016. Means they've started couple of things in 2002, and finally they have launched their services in 2006. And there is a one more very good link I'm having. Generally, history you don't need to know, but it is good if you know the couple of things here. Okay. So if you will check into this website, you will get the entire detail actually. Like if you will see in 13th March 2006, they have launched their first storage service, which is S3. In 3rd November 2004, they have launched the simple queue service, which is a messaging service. Right in December, 30th of December 2007, they have launched the simple database service. They have launched this EBS service in August 2008. And in 2006, they have also launched one more service called EC2. EC2 means this is the main service where we will launch all our virtual machines. Okay. In 2009, they have basically launched the management console. Then EC2 auto scaling they have introduced in 2009. So here long list they are having. So you can able to just check it out this list just for the couple of services, not all of them, and you will get the very good idea about it. Okay. That's how they have started their journey. So you will get the details here till 2021. Now let me just go here. Benefits we have already seen. So as I have mentioned, in 2002 AWS platform were launched. In 2003 new concept and plan formatted, right? They have created couple of plans. Then in 2004 first AWS service, which is SQS services launched. Then in 2006 they have done the relaunch of the AWS again, and they have started with EC2 service and S3 service. In 2009 virtual private cloud rollout, right? Then in 2012 first AWS customer event. Then 2013 the CIA adopt AWS as a provider. 2016 AWS hits around 10 billions in the revenue. Then 2017 AWS reaches around 100 service in total. In 2018 contract with the Pentagon and all, right? So these are the couple of achievement and how they have started. Here also you will get couple of more details. Design, SQS launch, AWS launch, right? EBS launch, so everything. The best website which I have shown you, which is this one. Here you can able to get the detailed. Okay, like S3 Glacier service they have launched in August 2012, right? So you can able to check. Redshift they have launched in August 2012, right? So you can able to see all the data. AWS CLI is launched for web developers tool, which is 2012. CloudTrail they have launched in 2013, right? Then they have a Kinesis database they have launched in 2013. So you can able to see all these things. So I've put all these links basically. So it is good if you know about these links. Okay. Now, main companies who are using AWS, which is Netflix, Intuit, Coinbase, Finra, Johnson and Johnson, Capital One, Adobe, Airbnb. Like there's a Hitachi, Palo Alto. So like Palo Alto, your URL filtering database is also at AWS only. Cisco is also using the AWS for couple of their services. Okay, so they have a very good customer basis. Okay, guys, I'm audible properly. Just confirm. Prashant, check your internet connection. Okay, or rejoin the meeting because I'm using LAN connection and I have a very high bandwidth connection. So generally, I will. There is no issue with the voice and all. Okay. Okay, now guys, let's try to understand the main thing, which is global infrastructure. You have to know the global infrastructure. So how I will explain the global infrastructure? Let me just go here. Let me close all of them. And you can just type here AWS dot or infrastructure.aws. If you will type this in Google, it will take you to this particular website. Maybe you will go here, or if you will type global infrastructure AWS, you will basically get into this particular website. Now here you can able to see whole detail, means what are the details we are checking. So let me just show you one thing first. Let me use this red color. See, if you will see here on my, this is the AWS console. In this console, if I will click and if I'll go here, it is loading now. And you can able to see we have a one region which is in US, which is North Virginia region. We have a one US East region, which is Ohio. We have a US West region, which is in California. We have a US West, which is Oregon. Means we have a one region at North Virginia, Ohio, California, Oregon. Then we in Asia we have a one AWS region on Mumbai, Osaka, Singapore, Sydney, Tokyo, right? In Canada they have a Central Canada, right? Frankfurt Island, London, Paris, so they have a regions are like this, means these are the regions where AWS is available. And these are the couple of other region which are, they will basically launch them soon. You can able to see. There are 12 regions that are not enabled for this account, means there are a couple of regions which is not enabled for my account because I'm using the free tier account, which includes the Hyderabad region as well. In India, they have a two regions, one in Mumbai and another one in Hyderabad. So because these are the very new regions, so that is the reason. Maybe they have a limited service over there. Okay. So now, so if we talk about the AWS global infrastructure, what happens? AWS has launched around 33 regions across the globe. And guys, each region has multiple availability zones. What is availability zones? I'm going to discuss in some time. What do you mean by the reason? Reason meaning AWS has their data center across the globe around 33 places. And all, see, one region can generally have multiple availability zones. And AWS has total of 15 availability zones. And they have around 600 plus point of presence. And they have a 13 regional cache servers. Okay, what is regional cache? Everything I'm going to cover. So if I'll go here, this is the AWS global infrastructure where you can able to see. See, in India, we have a Mumbai region launched in 2016, which has a 3 availability zone and it has a 2 local zones. Then we have a Hyderabad where we have a 3 availability zone, but it is not having any type of local, right? In Thailand, there's a region which is coming soon. So whatever you will see with the red, Means these are the regions soon they will start. In Singapore, they have one region. In Malaysia, there's a one region which is coming soon. In Auckland also, they have launched one region and they will basically launch it soon, right? So this is the global overview of the AWS regions. These are the regions which is available with the green color. With the red color means these are the availability zones which AWS is going to launch in few years. Okay. So like if you will check here, we have a Canada, right? In Canada, we have a Ohio, then we have a see, AWS has launched one more cloud, which is AWS Government Cloud. So right now, whatever if US government wants to deploy any of their resources which is related to the government activities, they will going to use this particular cloud only. And guys, this cloud is not open for normal users or the normal companies. Normal companies will deploy their resources on these particular regions like North Virginia, Central Canada, Central Ohio, Canada, right? Then Oregon, Northern California. Then AWS, they have a AWS government cloud here as well, right? So then they have a one more region they have launched, right? So across the globe, you can see AWS has launched their regions basically. Now, if you will go here, if I'll go into this region and availability zone tab, if I'll go into this Asia Pacific, in Asia Pacific, you can able to see think they don't have a up-to-date database right now. This data is not updated, guys. See, in Asia, they have shown one Mumbai region, but this Hyderabad is missing. So like we have a Mumbai, right? Then this is Thailand. This is for Malaysia. Singapore is up and running. And they have a one in Jakarta. And after that, they have one in Beijing. One is, and they have one here and here, Osaka. So these are the in Tokyo, right? This is how they have presence over the greater Asia. In Middle East, you can able to check, right? So you can able to check the details. So if I'll go into Asia Pacific and I can get the list here as well. All the details of all the regions. Okay. Now, let's try to understand what is AWS. So guys, maybe this particular PPT has old information. Okay. So AWS cloud spans around 105 availability zones within 33. This is the number because when they used to launch, they used to basically update that detail. My PPT is not up to date. So they have a 33, right? 30 geographical regions around the world with around plans for 15. So they are planning around 15 more availability zones and 5 more available regions in the Canada, Germany, Malaysia, New Zealand, and Thailand, right? So these are the couple of plans they are having in future. So what is region? So an AWS region is a named set of AWS resources in a geographic area. For example, the US East region, which is North Virginia region, is called US East 1 region, which is geographical area. Let's take an example for Mumbai. Region is a place where AWS has its infrastructure, means AWS has their data centers. Okay. A region has multiple availability zones or the data centers, or AWS has around 30 to 33 geographic location right now. So just remember one thing, what they used to have, they used to have a AWS region, and inside this region they have a availability zones. And guys, these availability zones is within the 60 miles. Means one availability zone. Let's say we have availability zone A, then we have a B and we have a C. So these particular three zones have a presence over around within a 60 kilometer or around 60 miles. Okay. Their presence have a presence around between 60 kilometer or within the 60 miles. Okay. Now, these availability zones have a multiple data centers. Maybe availability zone have a 3 data center. Maybe availability zone C have a 2 data center. Like so, all these availability zone they have a more than one data center as well. And all these data centers, what they are having your networking components. They have a different types of networking components. Just remember. So AWS cloud computing resources are hosted into multiple locations worldwide. These locations are composed of AWS regions, availability zones, local zones. Okay. Each AWS region is a separate geographical area. Each region has multiple isolated locations known as availability zones. So means each region has multiple availability zones. Just remember, each AWS region is designed to be isolated from other regions. This design achieves the greatest possible fault tolerance and stability. Now, guys, you can may ask one question: why AWS is launching multiple region across the globe? Why they are not just opening or everything? Why they are not putting all the resources just in one region? Because now anyone can access all the resources from this region, right? Why they are spreading over the globe, across the globe? There are multiple factors which they will consider. The first factor is the bandwidth. Let's take an example. Let's suppose there is our one customer, one company A, and that company is dealing with some of the project which is only for the Indian users. Now, if this company A hosted their web servers over the North Virginia region in USA, then because when these Indian customers they will access this particular web page into the North Virginia region, there is a lots of delay, there is a lots of bandwidth related issues, right? And also there's a one thing bandwidth. The second thing, government policies. See guys, there are lots of countries in Europe where government have lots of strict law. Means if some organization is storing the information of European users, then this information will store into the Europe or European countries area only. Like you cannot run your servers in US, and in US like they will not allow to store that information. So there are the company rules and regulations. So this is the second reason. So bandwidth, then government policies, right? And after that, the service. Maybe there are couple of countries where users is basically using couple of services a lot, or maybe there are a couple of companies where there are the few services which is not used by the users a lot, right? So that is also one of the reason, like service. Okay, so these are the reasons. And also the second reason, which is availability. Let's suppose if you will host all your resources over just one single region in North Virginia, and if there is any type of disaster is happening in North Virginia, what will happen? You will lose your entire data, right? So these are the four main factor which is considered by the cloud providers, and accordingly they are basically adding the details. No. In total, we have 33 regions, each with multiple availability zones. Okay. AWS region is a cluster of data center which are located on a separate geographic location. Every AWS region is physically isolated from every other region. Moreover, every region is independent of the location, power, cooling, physical security, etc. from every other regions. Okay. Now, so just remember one more thing, guys. all regions will not offer you all the services. Maybe let's suppose in North Virginia, AWS may be offering 200 services, but let's take an example in Mumbai region. Maybe AWS is only offering 180 services. Means you will not get all the services into one specific region. Just remember. In AWS, regions have names such as, like, see, if you have observed the name here, let me just go to into my console. If I'll go here, you can able to see all these regions, they have a name like this, right? North Virginia, which is US East 1, then Ohio US East 2. If you will see, look for the Mumbai, then AP South 1. If you look for Singapore, which is AP Southeast 1, right? So these type of names they have for every region. For Europe, London, they have a like EU hyphen best. For Ireland, they have a EU hyphen best 1, right? So like that, every region have the name. Just remember, okay? They have the names as well, like that. Now, let's try to understand the availability zone. So these are the same information which I have captured. You can see like AWS has a concept of a region, which is a physical location around the world where they cluster the data center, means where they will launch multiple data centers. And all these data center, like in this slide, they have mentioned up to 100 kilometers, which is around 60 miles. And this slide is I have got from the official document, just remember. And guys, all these particular data centers, they have connected with each other with the high speed fiber links, and these fiber links is known as AWS backbone network, just remember. Okay. And if you will see here, we have a one region, and this region has a three availability zone: AZ1, AZ2, and AZ3. And this particular availability zone has two data centers. AZ2 has three data centers, and AZ3 has two data centers again. Okay, so means region is just a one of the geographic location which have a cluster of data centers. Okay. Each AWS region consists of multiple isolated and physically separate availability zones within the geographical area. And these are the names and code for each region, like North Virginia, which is US East 1, Oregon, US Best 2. So whenever you will launch your resources, you can able to get these details. Now let's try to understand the availability zone. So as I have mentioned, we have a region, and each region has a multiple availability zones. And these availability zones have a multiple data centers. And all these data centers, they have a connectivity with the low latency, high speed fiber links. Just remember, okay? So availability zone, like high availability through the multiple availability zones. Each region, there will be at least two availability zones for the fault tolerance, means each region has minimum two availability zone. And if this particular availability zone goes down, we have another one from where we can basically run our resources. Okay, if there is a issue with this region, this particular availability zone, we can run the resources from the third one. So that is the reason they have a multiple availability zone just for the fault tolerance. Okay. And AZ is a combination of one or more data center in a given region. It is a logic grouping of data center in a given region for the service high availability. A data center is a location where actual physical resides or physical device resides. A single of couple of data centers are clubbed into one availability zone. Just remember. If I take example of Ireland, in Ireland region, we have a three availability zones. And guys, see, this Ireland region is your EU West 1. This is the code for reason. And after that, it has 3 availability zones. So availability zone will start with 1A, EU West 1A, EU West 1B, and EU West 1C. Let me just show you this part through the console. If I'll go here, let me go into North Virginia. I'm in North Virginia. So I'm just starting my BPC. Let me just go inside the BPC. And in BPC, let's suppose I will create a subnet. I'll select my demo BPC, and now you can able to see, you can give the subnet name, and now you have to select the availability zone. And guys, North Virginia is a very big data center, I can say, for AWS. It has around 6 availability zones: US East 1A, 1B, 1C, 1D, 1E, and 1F. Okay. In the similar way, if I'll basically change towards the Mumbai region, let me just go with the Mumbai region. Let me just show you the availability zones. So we don't have any type of BPC here. So what I will basically launch one BPC. Let me just launch one BPC. BPC test 01. This is just a testing one, guys. I will define the CIDR. I will use this any default CIDR you can try here. Go to into subnet. Now try to create a subnet, and you can able to see, select your BPC, and if you will browse here, you can able to see your in Mumbai region we have a 3 availability zones. We have a 3 availability zones: AP South 1, AP South 1A, 1B, and 1C. And AP South 1 is the code for Mumbai region. Just remember. Okay. Now, so an availability zone is a distinct location within an AWS region. AZs are designed to be isolated from failure in other availability zones. Availability zone equals to data centers. An AZ consists of one or more data centers. Each data center has redundant power, networking, and connectivity. The data center are housed in separate facilities, and all these data center have a servers. They are placed or they are placed in the availability zones or in the data center. So generally when we will run any type of instance, these instance we are going to basically put into these data center, and these data center have a racks and everything. I will go through with that picture as well, don't worry, in some time. So if you will see here, we have a AWS region, then we have availability zone A, availability zone B, and all these availability zone, they have a data centers. Now if you will go here, this is the Broadway. We have a region. Inside region, we have a availability zones. Inside availability zone, we have a data centers. Inside these data centers, we have a networking devices or network infrastructure. And this, on top of this network infrastructure, we used to install our VMs, virtual machines, or our EC2 instance. EC2 instance or VM, both are same thing. EC2 is a terminology of AWS. So if I'll go with the region details in the as per the India, so AWS has 2 data center infrastructure region in India. First one is Mumbai, second one is Hyderabad. So Mumbai they have launched in 2016. Hyderabad one they have just recently launched in 2022. Both regions have 3 availability zones. AWS launch an AWS local zone in New Delhi. And guys, now they have also started one local zone. Just remember what is local zone, I'm going to cover in some time. They have launched one local zone in New Delhi as well in 2022 itself. There are 6 AWS direct connect location. So in India, they have a 6 DX location as well. 2 in Mumbai, 1 in Chennai, 1 in Hyderabad, 1 in Delhi, 1 in Bangalore. Means it will basically cover the all the main IT cities which we have in inside the India, right? AWS has invested around 12.7 billion in India cloud infrastructure means they have invested huge amount just to build the cloud infrastructure in our country, which is India. The Hyderabad region, also known as AP South 2. This is the code for Hyderabad region. Just remember. ADO Mumbai region code is AP South 1. In this code, AP represents Asia Pacific. Here in South 1 represent the Mumbai region. Mumbai region has the zones. So like AP South 1A, 1B, 1C, these are the availability zones. All these regions and AGs are completely managed by the AWS, means everything is managed by the AWS or whatever resources are there. AGs in any region are interconnected with each other and can communicate. So this I have already covered, right? With the high speed links and all. So these are the same information. Okay, cool. Now, if you go into this global infrastructure, if you will click on regions and availability zones, now if you want to get more details, right? If you want to, let's suppose you want to look for India, Mumbai. So you can click on this one and they will tell you they have a 3 availability zone. Now they have launched 2 local zones. In Mumbai, we have a 2 local zones, okay? And you can able to see here. If you will go with the local zones tab, you can able to check the details here. 1 minute. Go back. Regions and availability zones. These are the couple of benefits and also you can read out these information if you want. Okay. So all these things we have in AWS region have the names such as US East 1, US West 1, right? This I have already covered, right? So don't need to discuss. Now availability zone. AWS region consists of multiple isolated locations known as availability zones. Availability zone is a grouping of one or more data centers. This is also we have seen, right? They are connected with the low latency, high throughput, and fully redundant fiber links. AGS gives customer the availability to operate production application and databases. This is where the actual compute, storage, network, and data resources are hosted that we as a consumer provision within our virtual clouds. All traffic between AGs is encrypted. Just remember, if there is any type of communication is happening between the AGs, it is encrypted. One availability zone does not mean only one data center. It can have one or more data center as well. Data traffic fee is generated. So generally, when there is a data transfer is happening between one availability zone to another, data transfer fee is generated if you wish to transfer data across regions. So there's a fee when you are basically sending any data. Let's suppose you have hosted one application in Mumbai region and you have hosted one application in North Virginia region. And let's suppose these application is exchanging some data, right? So that time you have to pay some data transfer charges. But if your data is transferring within the AZs, means let's suppose your data you are communicating this availability zone 1 will communicating with availability zone 2 and let's suppose in Mumbai region. That time you don't need to pay any type of charges because it's totally free. Okay, just remember. Now let's try to understand this edge location, but before that let me just see if I have anything else here. Edge location I'll come later. Let me just draw one of the diagram first, guys. So what used to happen generally? See, AWS, what they have done, they have basically, they are having one of the reasons. So let me just draw one of the reason here. So we have a reason. Let's suppose it is AP South 1, which is Mumbai region. Okay. Now this particular Mumbai region, it is having multiple availability zones. So let's suppose it has 3 availability zones. One availability zone here, one availability zone here, and one availability zone here. This is AZ1, AZ2, and AZ3. Now all these availability zones, they have a connectivity like this. And they are around, I can say 100 kilometers or 60 miles. There is no like a very specific document who will mention this distance, but this is the hypothetical numbers which I have taken. I have got the reference of these like 60 miles and 100 kilometers from couple of links, so which I am referring. Okay. Now each of these availability zone, they have multiple data centers. DC1, DC2. Here also they have a multiple data centers. DC1, DC2, DC1, DC2, DC3, right? And now, whenever we will deploy any type of resources, we will deploy, see these data centers actually. What these data centers, they have a rack environment here. In the rack, they have a different type of networking devices. And when we are deploying any type of resources, when we deploy any type of resources, we are going to deploy these resources into these particular rack where we have a bare metal servers. And these are the servers who is running the hypervisor. Guys, what is the name of hypervisor which is used by the Amazon? Write on the chat. What is the hypervisor name which is used by the Amazon? Yesterday I have discussed. Anyone remember the name? So Suresh has answered correctly. It is Zen. What is the next one? Zen is the previous version. Then they have a Nitro, right? So these are the hypervisor. And on top of these hypervisor, we are going to run our virtual machines. Okay. So this is how the architecture looks like with regards to these availability zones and all, or with regards to regions. Okay. And now this local zone I'm going to cover because I have a separate things for local zone. Let me just go through with the edge location. Mahesh, you are answering something which I will cover maybe in 4th class. Okay. So I'll take all these things when we will discuss in the 4th class. Otherwise, I'll answer your question after the session. Okay. So ask that one. So guys, during the class, try to ask the question from the current topics. Okay. If you have a question from last class or you have a questions from some future topics, ask when we are basically doing the Q&A by end of the session. So it will not break the flow. Okay. Now, edge locations are the AWS data centers designed to deliver the services with the lowest latency. Amazon has dozens of these data centers spread across the world. They are closer to the users than the region or availability zones, right? Often these particular locations, they have these located into major cities. So responses can be fast and snappy. A subset of service for which latency really matters, use the edge location. Services that uses the edge locations, right? So now, what are the edge locations? Let me just give you one example first. Let's suppose let's suppose there is a one user who is available here. These are the users we are having. Let's say these users are in Delhi, in India. And we have these two users. These two users is in Mumbai. Now, see, in Mumbai region, we have a DC1 where we have deployed one VM. On this VM, we are running the web server. Now, guys, tell me one thing. Let's suppose on this web server, what I am doing, I am basically running one of the movie. It just let's suppose this server is a let's suppose a OTT. It is running one of the OTT application. Let's take an example of Netflix. It's just a Netflix server, right? Where they have launched couple of movies, couple of web series, right? Now, tell me one thing. If this web server is accessed by a user who is in Mumbai region, who is in Mumbai, let's suppose he is opening this particular server, he watching this movie, so he will basically access like this through the internet. And let's suppose he is getting the response within 1 second. Now let's suppose we have the same. Now those are the users from the Delhi, they wants to basically access the same server. So guys, so they will also send the request like this. When they are sending the request, let's suppose it is taking around 4 seconds. Obviously it is the case, right? Because if you are accessing from Delhi and if you are accessing from Mumbai, because this particular server is available in Mumbai region only, right? So you can able to access properly. But if you are trying to access from the Delhi, and that right now, guys, this traffic is going through your normal internet. There are the delay always, right? You will get some type of bandwidth related issues. You will see some type of bandwidth related issues, right? So what they have done to basically overcome these type of issues, because guys, see, Netflix is used by the customers a lot across the globe, right? It's a very popular OTT platforms, and it is basically accessed by most of the users nowadays. Now, how this Netflix basically make the users experience very efficient, and whatever we are trying to play. Let's take an example. Let's take an example, guys. We have a Hotstar, right? In Hotstar, when there is a cricket match is going on, what we used to do, we everyone used to watch these cricket matches, right? So guys, tell me one thing. When you are watching this cricket match, do you expect if there is any type of delay is happening? Let's suppose, let's suppose on this particular server, they are running this particular stream of this cricket match. And if people is watching from Mumbai, they are getting the results right away. But when you are basically watching from Delhi, let's suppose you are getting all the results after 1 minute, or let's suppose after 20 seconds, which is not expected. Let's say here you are getting the result just within 1 second. So what will happen in that case? This Delhi users will not get the things, get the information properly right away, right? There are the delays. To overcome such type of problems, what they have done, they have basically created couple of edge locations. What they have created one edge location, let's suppose in Delhi, they have basically created one small AWS data center. On this small AWS data center, they have basically connected this AWS data center with this particular backbone network, this high speed fiber network. Now, tell me one thing. If any user who is watching this match into this laptop, if he's trying to access, let's suppose this user is trying to access, what he will do, he will basically send the request to Delhi data center, which is in Delhi itself. And from this Delhi, it will go through the AWS high speed links. It will reach to this VM and he will get the response. So now He will get the very fast response, and he will get the information accurate and on time, right? So such type of problems they will solve with the help of edge location concepts. Okay, that is the edge location, guys. If I will explain you the theory here. So edge locations are the AWS data centers designed to deliver the services with the lowest latency possible. Means the services where like where latency is the problem. Means these services you want to deliver as soon as possible. Latency is not the case. Like a Zoom meetings, like a Webex meetings, right? These are the couple of services, this voice related traffic, right? This telecom related traffic. You will not expect any type of latency on that. So these type of services we generally we will use with the help of edge location concept. We will make the user experience very great. Okay. So Amazon has dozens of these data centers spread across the world. They are closer to users than regions or availability zones, often in the major cities. So means these five type of edge location we are having most of the in the major cities basically, right? Edge locations are not used to deploy any main infrastructure. Means here you will not able to deploy any type of resources. Just remember, such a EC2 machine means we are not allowed to deploy any VM or any type of load balancer or any type of storage. No, nothing like that. They are used by AWS services such as AWS CloudFront. AWS CloudFront is a service which we generally use with the OTT platforms. This Netflix, Prime, they are using these particular AWS CloudFront service to deliver the voice or video related traffic or the media related traffic very soon. And the AWS Lambda is currently in preview, right? To create the data and reduce the latency for end user access by using the edge location as a global content delivery. So like this edge location will help for the customers who is dealing with some type of media related business, like a content delivery network type of customers, like your news channels, Hotstar, all these OTT platforms, right? So we have a CloudFront which uses the edge locations to cache the copies of the content that it serves, so the content is closer to the user and can be delivered to them very fast. Route Route 53. So the like CloudFront, Route 53, Web Application Firewall or AWS Shield and AWS Global Escalator. These are the four services which we generally use in the edge location. Just remember. Route 53 is just an intelligence DNS service. Like we have a global DNS like F5 GTM and F5. So this Route 53 is like a DNS service, and we have a lots of discussion over that basically. Web application firewall and AWS Shield, which filter traffic in edge locations to stop unwanted traffic as soon as possible, right? Global escalator, it it allows you to route requests for a key resource through Amazon global network, right? Even if the request is going halfway round the world. The request is initially routed to the closest edge location, then travels through the Amazon network. Means what will happen that you, let's suppose you are accessing one of the resource in North Virginia, and we have a Delhi. In Delhi, we have a one edge location, and we have a one customer here. So that traffic will go to Delhi location, and through this Delhi, it will enter into the high speed AWS fiber backbone network, and it will reach till the North Virginia, whatever the resource we have hosted. Okay, like that. So we will get the resource access very soon or the customer experience very soon. And these are the couple of links. Just go through with these links. And guys, in Asia, because I have written the Asia specific details in Asia, we have a couple of edge location. Like one we have in New Delhi, we have in Chennai, we have in Mumbai, we have a Pune, Bangalore, Korea, Bangkok, Japan. We have a Tokyo, Osaka, right? In Singapore, we have Hyderabad, we have Thailand, we have, right? So in Bangkok, we are having the same. Jakarta, Kolkata, right? Kuala Lumpur, Malaysia, right? So we have these particular edge locations available into most of the cities. And you can also check it out over this website, which is Global Infrastructure. If you will go into the AWS regions. So in regions, they will not tell you the edge location. So if you want to get the more details with regards to edge location, what you have to do, you can type AWS edge location, search over the internet, you will get the lots of details for the same. This is how this will work with the Amazon CloudFront and all, right? So let me just go here. I will open these resources for the same. So list of AWS services available by the region, right? Not this one, AWS as location network. And you can able to see in China, these are the regions, details and all, right? China, you can able to check here. Let me try on this link as well. Because generally these edge location concept is only useful for the CloudFront service, which is used for the hosting the AWS environment. Now, if you will see here, right, you will see this is the AWS Global Edge Network, right? And you can see if I will pick the India, you can able to see these are the around locations we are having. Right, you can able to check on the base of countries, Asia. From here I have got that information only, right? South America, Middle East, China, you can able to check all the details here. So this is the thing which you have to go through with that. Okay, so like the highlighted with the blue color is your edge locations, right? Then we have multiple edge locations as well, so you can able to see with this particular color. Now we do have a regional edge cache locations as well. So in November 2016, AW has announced one new type of edge location called as regional edge cache. Okay, these sits between your CloudFront origin servers and the edge location. A regional edge cache has a larger cache bandwidth than each of the individual edge locations, and because data expires from the cache at the edge locations, the data is retained at the regional edge location. And they have started like in Mumbai, in Singapore, in Tokyo. These are the couple of regional edge locations. So what happened, let me just tell you how these things works actually. This regional edge locations, what they will do, let's suppose we have one of the location here in Delhi, in Mumbai. Okay, let's suppose this is our North Virginia region for some time, and we are hosting one of the server here. On that server we have hosted one of the resource. Let's suppose we have hosted one movie, and let's suppose there are a couple of users who is trying to access this movie from India. What will happen, the copy of this particular movie is created into this particular one of the servers at the regional edge location, and that particular information is served from here. Okay, that's the main concept. Yeah, edge location is totally separate from the region and availability zones. Okay, it is just one of the data center which is created by the AWS into multiple cities just to increase the best user experience for the latency prone applications like your CloudFront, like your Route 53 and all. Okay. There's a one more concept we have with regards to the local zones. Now, what is local zones? This is the most important topics as well, guys. Local zones. So let me just go here. So as I have told you, like these are the couple of diagrams I have taken. As I have explained you guys, users are accessing the details from here, and the data which is available here, it will basically cached over these particular caches. So if user is accessing that data, these particular cache server will serve this particular request. Okay. Yes, it is only in Mumbai region right now. This regional edge cache. Just remember. Now, AWS local zones. Let's try to understand this particular part first. Okay, I'll go here. So we have a, let me close this, close this, close this. We have a local zones. Get started with this local zone. Now, so AWS has launched this new feature, which is a concept of new local zone. Like these are the places where they have introduced this new local zone. Let me tell you how it has worked basically. AWS and local zones are the type of infrastructure deployment that places compute, storage, database, and other select services close to the large population and the industry centers. Okay. A local zone is an extension of an AWS region. Means now they are just extending their regions with the help of this particular local zone that is geographically close to your users. You can extend any BPC from the parent AWS region into the local zones. To do so, create a new subnet and assign it to the AWS local zone. When you create a subnet in a local zone, your BPC is extended to that local zone. The subnet in that local zone operates the same as the other subnet which we are having into your BPC. Local zones have their own connections to the internet and support AWS Direct Connect, so that resources is created in a local zone can serve application that require low latency. So this local zone concept also they have just introduced to increase the user's experience by minimizing the latency related issues. Okay. We now have a total of 33 local zones across the globe, 16 outside of the US, and these are the locations like we have at Auckland, Bangkok, Delhi. In Delhi, we do have a one local zone, right? We have a one local zone in Kolkata. We have a one Muscat and all, right? So you can able to check out the list here. These are the list of local zones. Now, let me just tell you the things in detail. So these are the two links which you have to basically check out. Now, if you will see here in this particular diagram, we have a one region called US best 2. US best 2, as per my knowledge, it is, let me just see, is Ohio, right? So we have a region which is US East 2, which is Ohio, right? In Ohio region, what? We are having one availability zone, which is US best 2A, and we have a US best 2A, and we have a one more local zone here, which is US best 2 LAX-1. So LAX represents the local zones, just remember. So what will happen now? What will happen if I'll go here for Ohio? Let me just look for the local zone in the Ohio region. I think I will not able to see the details. So guys, just tell me if you can able to see this Ohio region here. I wanted to draw something. Not anything with the Ohio, right? US hyphen West hyphen 2. Okay, this is the one US West 2. Now, if you will go here, we are your US West 2, right? So if I'll go into my BPC console, if I will basically select my BPC, and if I'll go into availability zone, you can see I will not able to see any of the local zone here. Maybe it is not enabled for my account because I'm also using this free tier account right now. So what happens? Let's suppose, let me just go here. So what used to happen generally? Let's suppose, see, we have deployed one VM here, VM1. We have deployed one VM here, VM2, and we have also deployed one VM here, VM3. Now, guys, let's suppose this particular location is at Ohio, and we have this particular is at Oregon. Or in hypothetically, just consider, let's suppose this particular is in Mumbai, and we have this particular is at Delhi. Now, what used to happen? See, let's suppose you are using this type of setup, but you know your 90% users is from the Delhi NCR only. If your 90% customer is from the Delhi NCR only, then guys, tell me one thing. It is any making any sense we can deploy our VMs into these two subnets, which is in Mumbai? No. What we can do, we can deploy all these VMs here into this local zone. So we will get the speed which is very fast here because they are very nearby, if because our customer database in Delhi NCR only, right? So what will happen, see what AWS have done, rather than creating a separate region here, what they have done, they have created one a small data center, because by end of the day, in region we have a availability zone, and in availability zone we have a data centers, and inside these data centers what we are having the servers. On that servers we are running our resources. So guys, by end of the day, what we are getting the servers. So what they have done, they have basically built the similar type of data center here into the Delhi location. So it is just a extension on your regions, means they have extended your regions. Okay, it is not similar to your edge location, and all edge location is a different concept. And what used to happen, let me tell you, see, maybe in edge locations, what we have a limitation, we cannot able, we are only allowed to use edge location just for the route 53 service, for the CloudWatch service, right? Only 4 services allowed in the edge location, but in local zone you can able to use all the services, you can able to deploy the VMs and everything, but at the edge location you are not allowed to deploy any VMs. Just remember that's the difference. Okay, here you can able to launch your compute resources. And guys, this data center and this data centers, they have a connectivity with the high speed fiber link, so you will not get the speed related issues. Okay, that's the concept of local zone. It is just a extension. Okay, you can also check out these things here for the more details with regards to local zone and all, right? Local zone subnet follow the same routing, even though guys routing and everything is similar, whatever you will perform with regards to your BPC. When we will do all these practical, you can able to understand the things. Available local zones, you can able to check, right? These are the available local zones availability and all, right? You can able to see connectivity options. This is how your local zones connectivity looks like, right? We have a availability zone A, availability zone B, and we have a local zone A. And we have a two VMs here. This is one VM and this is another VM. And we have an internet gateway. We can use this internet gateway to connect with these users. So like it, these local zones supports the internet gateway. They supports the net gateways as well, right? We can able to deploy the net gateway. They will also support the VPN. You can able to create the internet gateway and site to site VPN with your on-prem data center. This is a very good use case basically, right? With the help of local zone. You can create IP site to site VPN if your office is at Delhi NCR and you are using the local zone at Delhi, right? It supports the direct connect, means these are the services which is supported by the local zones, guys. Okay. Okay, so these are the couple of connectivity options which is provided by the local zone. You will able to read the theory. Run low latency application at the edge, simplify the hybrid cloud migration, meet stringent data resiliency requirements and all, right? Deploying the local zone. In AWS can provide a web interface that you use to manage the local zones and all, right? From CLI, so you can able to deploy these local zones with the help of management console, which is web UIs, AWS CLI, and AWS SDKs. Okay. Pricing, there are no additional charge for enabling the local zones. So it's a free service. Just remember. Okay. It's a free service. You pay only for the resources that you deploy in the local zone. AWS resource in local zone have different pricing than they have. So guys, this is just remember one thing. See, let's suppose you have deployed one VM. Let's say VM1. If you are deploying this VM with 8 CPU, 32 GB of RAM, and 200 GB of SSD. Let's say if you had deployed this VM into the Mumbai region. In Mumbai region, maybe you have to pay 1 USD per hour. If you will deploy the same VM into North Virginia region, maybe you have to pay 0.75 USD per hour. If you will deploy the same VM in the local zone, maybe price is different. So these things you have to basically take care before deploying all these things. You have to see how much charges are there and all. Okay, just remember. Now there's a one more concept we have in AWS, which is AWS POP location, point of presence location. So in additions to the AWS regions and availability zones, AWS also operates a globally distributed point of presence network. These POPs host Amazon CloudFront, a content delivery network, Amazon Route 53, a public DNS resolution service, AWS Global Escalator, and an edge networking optimization service. The global edge network currently consists around 410 POPs location across the globe. So guys, this POP location you can think like a edge location. Okay, POPs is similar to edge, but these POP location, this concept of AWS POPs is from decade, but this particular edge location recently they have introduced. So maybe in a couple of years you will not able to find these POP rated concepts. Okay, just remember. Another part of AWS global infrastructure are the point of presence. POP is an intermediate location between an AWS region and the end user. For AWS, POP is a data center owned by the AWS and a trusted partner. Means now this guy's POP location, whatever data center they are having, it is either maintained and managed by the AWS or either some of the trusted partners, which are utilized by the AWS services like content delivery and S3. Okay. Point of presence is a network interface points between communicating entities. A POP is located in a data center that house servers, routers, which is having like your servers, routers, network switches, multiplex, other networking device and all, right? POPs are located at the co-location centers and the internet exchange points. A POP is a local access point for an internet service provider. POP consists of high-speed telecommunication equipment that helps the customer to connect with the internet via their POP location or via their ISPs and all. Okay. What is the main difference between POPs and edge location? A point of presence means we are using internet service provider backbone. Just remember, means if we have connected with any of the POP location, whatever the connectivity we are having between this POP location and the AWS region is through some of the internet service provider like BT, Verizon, right? Airtel, Tata, all these internet service providers to connect with the AWS region. Edge locations, on the other hand, are the point of presence with full deployment of advanced network infrastructure by the AWS. Means when we are using edge location, so edge location has a connectivity with your AWS region with the help of AWS deployed backbone network. Just remember, okay? So I hope you got the main difference between POP and the edge locations, okay? These are the couple of terminologies, guys, which you need to know, because when you will give your AWS exam, they will basically put these type of details actually. So you should know the basic things of these. That's it, okay? Now let's try to understand. There's a one more concept called AWS wavelength zones. So guys, let me tell you, like we have a local zone, right? In local zone, what happening? It is just a extension for the region, right? But see, let's suppose we have a region here and this is, let's suppose, a local zone for some time. This local zone and this region, they have a connectivity with the high speed fiber links. But this AWS wavelength zone just used for the 5G communications, just for the 5G communication. Or the, see, this particular thing generally utilized by the users, which is it in a remote areas. Some company, let's suppose they are in the remote areas where we are not able to basically do the cabling stuff for the connectivity. We are just have a dependency over the 5G networks. Okay. So these type of, if we have a these type of customers and we wants to basically connect them, we have to go with the wavelength zone concepts in AWS. Let's try to understand what's that. After I'll give you the example and all. So AWS wavelength zones provide 5G telecommunication connections inside an AWS region. Means they are basically designed just for the 5G telecommunication. Okay. Wavelength zone embed AWS compute and storage capabilities within communication service providers data centers at the edge of their 5G network. Our AWS wavelength is available in 30 cities across the globe. Okay. 5G devices can reach applications running in wavelength zone without ever leaving the 5G network, allowing them to take the advantage of the 5G bandwidth and latency. Okay. AWS wavelength zone are embedded within the 5G mobile broadband network. So let me just go here. Let's try to understand this particular diagram. In this diagram, if you will see here, we have a here customer systems over the AWS environment, right? And then they have a connectivity through one of the company called KDDI backbone, and KDI is a one of the 5G service providers. Okay. And all these smart devices, robots, cameras, drones, industrial devices, they have a connectivity with this KDDI tower through the 5G tower, right? They have a connectivity using the 5G cellular connections, okay? And they have a mobile gateway. And this particular data center, this particular area, this data center, I'm talking about this area. This area, this particular data center is belongs to KDDI company, this entire DC, where they have a hell lot of components. So what used to happen, guys? See, they have up and running these data centers. So what Amazon used to do, Amazon used to build their they will put couple of their devices inside this particular customer data center. This is known as AWS wavelength zone. And after that, this particular customer system, whatever we have here previously in AWS cloud, now they have a similar type of setup into the customer data center itself. Okay, so whatever traffic is coming from these users, it will directly go to the mobile gateway and it will directly go towards the customer system. If anything they needs to fetch from here, then this traffic will go through the KDDI backbone network till here. So means what we are, AWS wavelength zone is a region based extension, and this in this extension what they are just building some of the AWS related data centers over some 5G companies data center. Means whatever the 5G companies we are having into their data center, we are just putting some part of our services. Okay, if you will see here as well. So these are the couple of use cases for 5G. This particular solution, like first is like we have a machine learning assisted healthcare environment, healthcare devices, connected vehicles, right? Smart factories. We have a real-time gaming, AR, VR, and XR related devices, right? Interaction with the live video streaming and all. Right? These are the couple of use cases we are using this wavelength zone service from the AWS. Here, if you will see, we have a AWS region, we have a internet, we have a connectivity between AWS and this 5G company data center, and where we have hosted one of the AWS resources, where we are running, where we are now this company is running couple of application, and these they are the user who is basically accessing these applications through this particular 5G network directly. Rather than see if this is not the concept previously, what the traffic coming from here, it will used to go here, then it used to go to AWS, then used to come like this. So that was the latency and there was the delay. No. So AWS wavelength zone are embedded within 5G mobile broadband networks and are deployed within the data centers of large telecommunication provider. Means what happens, AWS used to deploy their resources inside the data centers of the large telecommunication providers, deploying the AWS resources such as BPC subnets, EC2 instance, and the elastic volumes to an AWS wavelength zone allows end users to connect to these resources without ever leaving the mobile provider network. Means we don't need to go from here and there basically to reach to the AWS environment by reducing the number of network hops and eliminating the need for the any traffic to traverse the public internet. Developers can offer ultra low latency and increase reliability of 5G applications such as live video streaming and interactive gaming. Okay, so this is the overall concept of wavelength zone. AWS wavelength zone are currently available through the Verizon. There is a one telecommunication provider which is Verizon in the United States, KDDI in Japan, SK Telecom in the South Korea, Vodafone in UK and Germany, and well in Canada. So these are the places where this particular wavelength related concept they have introduced. Let me just tell you how the traffic flow for this particular system, so you will get the idea. Okay. Now, Let's see. I am a user and this is my mobile phone. Okay, this is my mobile phone. And I'm in one of the remote location. Let's suppose I'm at one of the remote location where I just have an option of using 5G internet connections. Okay. Now, this mobile connection have a connectivity with one of the internet tower, right? So it has a connectivity through this tower. And this tower ultimately have a connectivity through the data center. Let's suppose this is a Vodafone. I'm using the Vodafone SIM. Okay. For example, right? So this is a Vodafone signal tower, right? And this particular Vodafone signal tower have a connectivity with the Vodafone data center. This says Vodafone DC. And after that, I have here AWS. This is AWS region I am having. In this region, I have hosted one of the VM. This is the VM where I am running my traffic, right? This Vodafone DC and this AWS region, they have a connectivity somehow through the internet service provider. Okay. Now guys, tell me one thing. See, if I'm trying to access this particular service this time, what will happen? When I will try to access this particular server from this mobile, I am trying to opening this VM, what will happen? My traffic will flow like this. And guys, this is internet and internet is always slow, right? This was the concept we will be having previously. Now, if what we will do, see the same application, what AWS have done inside this Vodafone data center, AWS has created couple of he has just placed couple of servers. These are the AWS servers. And on these server, let's say I'm running my VM now. Now, guys, if I'm accessing this particular VM this time from this machine, I will get the response easily. Rather than going here, I'm just accessing because I have created the same thing, same source over this particular 5G company data center. This is the extension of wavelength. This is the concept of wavelength zone. I hope guys wavelength is clear with everybody. I'm explaining these things because you may see some of the customers may ask these type of questions, so that is the reason. Okay, I am trying to cover here so you will at least get the whole idea. Now let's try to move further. There is a guys one more concept available which is AWS Outpost. This is also a new concept which is launched by the AWS. So AWS Outpost is a fully managed service that allow customers to build and deploy AWS storage capacity at customer sites. Outpost extend AWS infrastructure, services, tools, and APIs to the customer locations and enabling a hybrid delivery experience. So this is the concept of AWS Outpost. And right now they are mostly focusing towards the storage capacity type of services. AWS Outpost can be created in almost any customer provided space, including like a data centers, co-location facilities, customer on-prem facilities and all, right? So this is the concept of AWS Outpost. Okay. Now, guys, there is a one more thing. What are the things we have to consider before picking a reason? How AWS will reach their servers located in the customer DC? They will basically they definitely have a contract with some of the internet service providers, right? And they will basically create a MPLS or the point to point connection with them. Okay, that's how this thing works. Okay. Now, what are the things we have to consider before deciding a reason? Means what are the factor we have to check before deciding the reason? Because by end of the day, let's suppose there is a one company called ABC, and this company wants to deploy their resources. Now, before deploying these resources, what we have to choose our data center. We have to choose a location, right? According to our customers, according to our users, we have to consider all such type of factors. We will decide one reason or maybe two reason, which basically, so one reason become a primary and another reason become a secondary just for the backup purpose. So what the first thing, which is proximity or the latency. So let's suppose, guys, your company, which is SIANETS, let's say it is in just in India. And now we have decided to run our services over the North Virginia region. Then definitely there is a latency when any user will access the server services from the North Virginia, because my traffic will flow from one region to the, or like one part of the word to the another part of the word, right? So there is a huge latency. And if I will deploy the same thing into the Mumbai region, I will get the fast response. So what we have to always look for the latency means we have to always pick a region which is closer to you and your data center, your customer, so you will get the better connectivity. This is the one thing which you have to take care. The second thing, services and features. Let's suppose there are a couple of services. You have a region nearby which is Mumbai, but let's suppose in Mumbai region, whatever services you needed, they are not available. These services only available, let's suppose, at Singapore region. Then what we have to do, we have to also check what are the services available in our region, what are the features available in our region, and accordingly we have to basically check. Okay, so we have to look for the services, features, software releases and all. The second thing, we have to look for the cost. Sometimes you may face in, if you are deploying some VMs in Mumbai region which are costly, if you will deploy the same resource in Singapore which is in low cost, right? So you have to look for the cost as well, because cost changes from region by region. Then we were SLA. We have to look for the service level agreement. And service level agreement is also varies from region to region. Means what are the guarantee AWS is giving you for the availability purpose. Let's suppose you in Mumbai region they are giving 95% is the availability of your resources, but for Singapore they are giving 99%. Then you will definitely you will choose the 99% availability, right? You will choose the Singapore region because here you have a high available resources. Okay, we have a compliance means, because every country have some rules and regulations, so you have to follow the compliance policies as well, right? And according to these compliance policy, you have to choose a region where you will basically deploy your resources. So these are the around 5 things which we used to consider before deciding where we have to deploy which resources. Okay, so these are the things you can like evaluate regions for deployment, compliance, latency, cost, service, and features, right? You can able to check it out all these details. You can go with the multi-region deployment as well, right? Just for the backup purpose. So just read these articles, guys. Whatever I'm putting, just read. They will definitely help you to understand the basics of AWS. Okay. Now, one more thing I wanted to show you, and after that we will move further. Let me just type for AWS Fiverr map. Okay, these images are not coming properly. Are you guys able to see this particular image properly? It's visible. Let me just. Now, guys, see, when it comes to the AWS backbone network, as I have mentioned, what used to happen? See, all the regions, all the 33 regions which we have across the globe, right? What these regions, they have a they have a connectivity through the sea as well. Okay. Each region has a connectivity through the high speed fiber links. Okay. So that particular connectivity thing is known as a AWS through the sea. They have a connect means each region has a connectivity with the other regions. That is known as AWS backbone network. Okay, let me just see if I can able to get some good picture for the same. Let me open this as well. Let me open this as well. Some details they have removed. Actually, previously everything we can able to check, but now I'm not sure why they have removed the details. Copy the image. So if you will see, they have a connectivity of each and every regions like this. Like if you will see here, your London region has a connectivity with the North Virginia region through these fiber links through the sea, right? So guys, these are the interconnected dedicated links. So that is the reason if you are exchanging any type of data between these regions, which is very, very fast. Okay, and that is the also main reason they have launched this local zone concept, right? This wavelength zone, these your point of presence, right? All these things, because now if your resources are at the edge location which is in Delhi, and if you want to access the main resource which is in North Virginia, because that resource will follow the path, it will go through with the AWS internal backbone network, which is a very, very fast network. So you will get a very, very, really high speed and all. Okay, so it has a connectivity like this, just remember. Let me just take this picture as well. Previously they used to have a one picture where you can able to see inside the sea as well. They have a connectivity, right? If you will see, your Mumbai region has a connectivity with the Singapore. It has a connectivity with the Bahrain, right? This is all this particular thing is the AWS backbone network. Just remember. Okay. Yes, it is like an internet submarine map. Means these are the dedicated fiber connections, like when we used to connect two computers with with this ethernet cable. It's the same setup. Okay, it's like a similar thing. Okay, so now I hope guys you understood the global infrastructure. This is what you wanted to know with regards to these global infrastructure and all, right? These are the all are the theoretical concepts only. Now guys, let me just tell you the some basics about the AWS services. So with regards to this AWS services, in AWS we have a two type of services. So in AWS, we generally have a two type of service. One service is known as a global services, and the second type of AWS service is the region specific service. Global service means this particular service is available globally. Means whatever you will do inside this service, which is have a global presence, it will apply to all these 33 regions. If you will create, there is a one service called IAM, identity access management, identity and access management. Let's suppose if you will create one username called Hemu, then this user can able can have a presence over across all these 33 regions. These are the global service. Then we have a region specific service, means these are the services which is available only have a scope just within that region. Means if you will deploy anything, let's suppose we have a one service called BPC. If we will deploy this BPC in Mumbai region, then the scope of this BPC is only limited till the Mumbai region only. Okay. So we have a two types of global service and the region specific service. So AWS IAM, AWS organizations, AWS account management, AWS network manager, Route 53, AWS CloudFront, AWS Web, AWS Key Pair, AWS Certificate Manager for CloudFront, AWS Global Escalator, AWS Shield, and AWS S3, and the direct connect gateway. These are the global services. If you will, let me just show you. See, if I'll go into my console, if I will just try to open this BPC, let me change my region because I used to work in most of the time in North Virginia region because resources are cheap into this North Virginia region. See, in North Virginia region, for hypothetical, I have one BPC with the name of called BPC demo. I have around these particular subnets, these 6 subnets. I have a route tables. I have an internet gateway, right? And let me just open one more service called EC2 into the same North Virginia region. And if I'll go into my instance tab here, oh, I have deleted all the instance here as well. Now, see, now whatever I will deploy here, let's suppose if I will deploy one instance, I'm just deploying just for your understanding, guys. Do not think much what I am doing here because we will discuss everything in detail. Here I'm just deploying just for making you some understanding of it. Okay. I will deploy on public network, select existing one. Just create this machine. I have created one machine here. Right now you can see this is the machine which is in the under deployment. Okay. Now if I will open the one more tab here for BPC, one more tab for EC2 instance. See, this is my subnet tab for North Virginia region. These are subnets, and this is the machine I have into the North Virginia region. See, which is up and running, right? And this is the detail of that machine. It has a public IP, private IP, everything up and running. Now, if I will go here into this tab, if I will change my region and if I will select here, let's suppose Mumbai. Here also for EC2, let me just change my region and I will select Mumbai. In Mumbai, if I'll go into the subnet tab, and for EC2, if I'll go into this instance tab for Mumbai region now, are you able to see this particular VM which I have into my North Virginia region? Are you able to see into this Mumbai region? No, it is not available. Are you able to see the subnets here into Mumbai region. I have a subnets here into my North Virginia region, but these subnets is not available into this particular Mumbai region. Means this BPC, EC2, these are the region specific service, means they have a scope within that particular region. Okay. Now, if I will open one more service called Route 53, if I will open one more service called S3, if I will open one service called IAM, and I will open one service called Certificate Manager. Now, when you will open this Route 53 service, see, when you have seen the service for EC2 or BPC and all, see what we are able to see. We are able to see this region tab. We are able to see these regions. But for Route 53, are you able to see any region? It's global, right? Means whatever detail, whatever DNS record I will create inside this Route 53, it has a basically it is available across all the regions. Means it is valid for all the regions. This is a global service which has a global scope, means it is valid, it is available across all the regions. And S3, it is also global service. IIM, it is also global service. Certificate, I'll go into the list of the certificate. Sorry guys, certificate is a region specific service. Okay. That is the reason, because if I will change this to North Virginia, in North Virginia, I have these two certificate, which is I have created. These are the publicly available certificates. Okay. So see, I have a certificate. So your ACM is a, let me, I have to remove this part. AWS Certificate Manager. Yeah. So AWS Certificate Manager for CloudFront. If we are using ACM just for CloudFront, then it's a global. Otherwise, the normal ACM is a region specific service. Just remember, I have a CloudFront here. Okay. So if we are using the certificate for CloudFront, then it is a global service. Okay. Then region specific service like AWS BPC, EC2, containers, databases, all these are the region specific service. So I hope it is clear, guys. Whatever services, let's suppose, let's take an example for a region called, if I'll take a region called North Virginia. Rise in North Virginia, if whatever BPC I will create, whatever component I will create for EC2, they have a scope within this particular region only. Okay. But if I will create anything with regards to S3 or with regards to Route 53, they are the global services. They have a global presence. CloudFront is nothing. It is just one of the service which we use to basically host our media related services, like your OTT platforms they will use to host their videos, streaming and all, right? So we have a dedicated lectures on CloudFront, don't worry. Okay. I'll take 2 classes for CloudFront where we will understand everything with regards to that. Now, guys, I hope it is clear to everyone, the global services and the region specific services. I hope it is clear with everybody. Write on the chat if it is clear to everyone. So as I have mentioned, in AWS, we have a 2 type of services. AWS operates 3, so like they have mentioned 3 services, different categories of service based on their fault tolerance boundary, like zonal service, regional service, and the global services. AWS provide a lot of services, and use services are either at global, regional level or at the availability zone specific or cannot be accessed outside. Most of the AWS managed services are regional based services like EC2, ELB, BPC, etc. And we have a few of the service which is IAM, Route 53, CloudFront, which are your regional specific service. So guys, they have mentioned this zonal service because see, there is a one thing which is subnet which we used to create at the zone level. Okay. And I don't think So like generally, uh, he has just meant I have added one more point, the addition one, but we have a two subject region specific and global, because see whatever subnets we will create, they comes under the region only. Okay. So as I have mentioned, global service has a presence globally, and after that we have a region specific service where we will create a resources at the region level. Okay, these things we will discuss later, like what is elastic computing and all. It's not a part of our today's class topic. Don't save it now. Now guys, before going into to understand this on-prem network, we have already I have already covered that thing in our last session. What is on-premise network, right? And all, what is data center, what is branch office, what is HQ. But today's also I will go through with all that particular detail. Okay. So before going into that details, let's try to understand. So guys, generally what we generally used to have a data centers like this. In this data center we have a rack. This is your rack. Inside this rack, you can see we have a couple of networking devices. These are the routers, switches, firewalls, and all, right. So we have a similar type of setup as well over the AWS environment. In AWS data centers, what we have in AWS DCs, they have these type of racks only. On these racks they have a routers, they have a switches, they have firewalls, right? And they have a bare metal servers where we used to run our virtual machines or our EC2 instance. Okay, so data center virtualization is a process of creating a modern data center that is highly scalable, available, and secure. With the data center virtualization products, you can increase IT agility and to create a seamless foundation to manage private and public cloud services alongside traditional on-prem infrastructure, right? So this is the one of the picture for a data center where we have a multiple racks, multiple devices, right? We have a different type of power supplies, everything is there, right? So generally a data center is a building or a dedicated space within a building or a group of buildings used to house computer systems, associated components such as telecommunication and storage systems. It includes redundant or backup components and infrastructure for the power supply, data communication connections, right? Environment control related device like air conditioner, fire, suspension, and all, right? And various security devices. Data centers can vary widely in terms of size, power requirement, redundancy, and overall structure, right? Data center is more advanced and complex version of server room. Okay. Now, generally, these are the main difference between data center and servers. I will not discuss these things because it's very basic. So in data center, generally what we have inside a data center, you have one of the cooling system who will basically cool down all the resources, because in data center there is a huge heat is generated by the networking devices. So you need a cooling system. You need a softwares where we will run our application, where we will run these softwares, right? Inside our Linux and Windows operating system, we have a servers where we are running multiple operating system, multiple application on top of this. So we have a storage, right, where we will store the data. We have a networking devices like routers, switches, firewalls. We need an infrastructure, right? We need an environment monitoring tool, cabling, power backup systems, and all, right? These are the main component which we needed for the data center perspective. And in data center generally, all these data center, they have a connectivity through these fiber cables, right? So we have a fiber cables, we have a Ethernet cables, right? All these type of cables connected across these data centers, right? All the racks, basically, they have a connectivity through these cables just to provide the network connectivity. This is how all the component inside this data center is connected, right? We have a server form. So all your servers available here, right? These servers, they have a connectivity through this particular cooling systems and all, right? They have a energy related things and all, backup related things and all, everything, right? And all these users, they will have a connectivity through these servers by end of the day. So this is the another example for this one. Now, generally for on-prem data center, what are the component we need? We need a physical location, hardware ownership, direct control, data security, resource allocation. All these are the tasks which we need to perform with regards to a data center, right? I will not discuss problem and challenges because we all are the experienced person, right? So generally what used to happen, guys, with the on-prem data centers, the main problem with regards to the limited scalability, high maintenance cost, resource wastage, limited disaster recovery option, space constraint, right? Energy consumption, long deployment times, lack of flexibility, obsolete hardware, vendor lock-in, and complex backup and recovery. These are the couple of problems we will be having with regards to the on-prem data centers, right? And generally, guys, what used to happen inside and server, what we have a hardware, then we have operating system, then we hypervisor, and over this hypervisor we are running the virtual machines, right? This we have already seen in our yesterday class as well. Okay, now, so this is the some basic idea about the data center. So let me just draw one of the diagrams. Generally, in a data center, basically what we have a servers like application servers, web servers, database servers, SNMP servers, DSCP servers, DNS, NTP, internal apps, syslog, AD servers, right? These type of servers you may found in a data center. In a data center, we have a networking devices like firewalls, routers, L3 switches, L2 switches, WLC, access point, load balancers, NAC related device like ICE and ClearPass, IDS, IPS, internet providers, laptop, desktop, licensed network module racks, right? All these are the networking component which we needed for the on-prem data center, right? For storage, we need a storage solutions, right? Software, we need our operating system and application for to run our business. Cabling infrastructure, we need fiber runs, Ethernet cables, patch panels, etc. Power consumption, we need power cables, power port, power generation, UPS, and all, right? We need a cooling infrastructure and we need a physical security as well. We need a physical security, right? So we have to hire a couple of people who can basically protect from the external theft and all, right? These particular data center. So these are the like components we generally have in your on-prem DCs. Now, if I will basically compare these on-prem DCs component with the AWS component, then this is the list. So what we have, guys, here, see, in your data center, every networking device, it has a IP address, right? So we have to basically create a subnets, right? We have to do the IP planning. We have to create a subnet and all. We have to create a subnet with the proper CIDR range and all, right? Same thing we have to deploy in AWS, and it is known as CIDR, classless interdomain routing, right? So DCIP range is equals to CIDR in AWS. VLANs or L2 switch in AWS is known as subnets, means whatever VLANs we will create in your L2 switches, or right, it is similar to the subnets whatever we will create in our AWS environment. Routers and L3 switches, we have a routing tables, means to send the traffic, right, to process the traffic at L3 layer 3, what we need a router who can perform the routing related tasks, right? So we have a route tables, we have a routers in your on-prem DCs. In AWS, we have a routing tables to achieve the same task. We will not get the access of router, whatever router they are using in backend. This AWS people, they will not give you the access of that router. We will just give a access to this route table. We can able to modify the entries and we can able to remove the entries and all from that table. Okay. For firewalls, Like in on-prem, we have a Palo Alto firewall, Cisco firewalls and all, right? In your AWS, we have a security groups, which is also act as a firewall. Apart from this security, we can also deploy the Palo Alto firewall, Checkpoint firewall, but the virtual images. But in DCs, we have a most of the time hardware box here, okay? We do have a access control list ACL concept in your switches or in your routers. The same access list concept available in your AWS, which is known as network access control list NACL. We have a WAN router, which will basically provide you the internet connection. In AWS, the same thing is known as internet gateway. WAN router, so net gateway and net instance is also act as a WAN router. Egress only internet gateway is also a option we have. So these are the three things which generally act as a WAN router in your AWS environment. In VPN devices, in on-prem we have a firewall and router as a VPN devices. In AWS we have a VPN private gateway. We have a customer gateway. We have a virtual private networks, VPNs. We have a MPLS connection in your on-prem DC where we have a BPC endpoint concept. MPLS and SD-WAN concept is known as BPC peering. Okay, to connect to sites in on-prem, we can use MPLS or SD-WAN, right? Which is known as BPC peering in your AWS. Ethernet ports is equals to the elastic network interfaces. DSCP server, we have a DSCP option set. So DSCP server, which is equals to DSCP option set in AWS. DNS server is equals to AWS DNS server or AWS Route 53. Syslog server is equals to BPN Philologs. Sorry, BPC Philologs in AWS. F5LTM, GTM, and WEF. So for F5LTM, we have a AWS Elastic Load Balancer. For GTM, we have a Route 53. For WEF, we have a AWS WEF. So these are the couple of comparison with regards to the on-prem component and with regards to the AWS component, guys. Now, what are the ways to access these AWS resources? So generally we have a three ways. Let's suppose you want to create couple of services. What you want to do? You want to create couple of services on AWS environment. Then how you will access generally? Tell me one thing. Let's suppose you want to access a router to do some type of configuration. Let's say you want to do some config on Palo Alto firewall. What are the ways to access this Palo Alto device? Tell me, guys. What are the ways to access this Palo Alto device? We have a Palo Alto firewall, a beat any firewall, and we wants to basically do the configuration and all. So the very first way, which is web UI, we uses HTTPS protocol or HTTP also we can use, right? The second way, CLI, command line interface, and the third way, I think nobody has mentioned the third way. I can see they have mentioned GUI and CLI. What is the third way, guys? No, not console. Console is CLI only, right? Like SHS, Telnet, and console it's CLI. Yeah, I got the answer from Swiss API. Not management. Management, yeah, management is also comes under the API. The third way, which is API, which is also known as automation, or it is also known as REST API, right? So guys, in similar way, like we have these methods to access the Palo Alto firewall, in AWS also we have the same option. We have a first option which is web UI, which is known as AWS Management Console. The second way of accessing this AWS is known as AWS CLI, command line interface. And third way of accessing or creating the AWS resources is AWS SDK, software development kits, which includes your Python language, Terraform, automation, like your REST APIs, everything comes under this SDK. So these are the three ways to access your AWS environment. If you will see here in this diagram, we can able to control, we can able to create, delete, modify AWS resources with the help of AWS Management Console, which is the web UI, AWS CLI, which is a command line interface, and the AWS SDK. So these are the three ways to basically access the AWS cloud. So the let me just show you. If you will see here, this particular thing is known as web UI. This is the web UI, AWS Management Console. Okay. If I'll open my command prompt, AWS help. Right now, see, I have not done the configuration, but you can see I have installed this AWS CLI application. If I will type AWS CLI, see, this is the thing. I have already installed this AWS CLI on my laptop. Okay. So we do have a ways to access this particular thing. So like that, we will get the CLI. Okay. AWS S3 list. Let me just see if I can able to see. No, I'm getting some of the error because I'm not have good idea of the AWS CLI. I can okay. So these couple of commands we can try when we will do I'll perform couple of practicals with the help of CLI as well, right? Apart from that, basically we have this particular ways of AWS tools and SDKs. Means when you are basically communicating with the AWS using the Terraform, which is automation tool. If you have created any type of Python tool to communicate with the AWS, right? All these comes under the AWS tools and SDKs. Okay. And if you want to see the list of all these things, you can basically go and open these particular articles. So I'll go with the AWS official one. And meanwhile, guys, I have created that machine. Let me just delete. I don't need it actually for now. I'm just terminating it. Otherwise, it will unnecessary bill. So we have a three ways: AWS Management Console, command line interface, and software development kits. If I will open AWS software development kits, let's see. Can open this website. So guys, now you can utilize these many programming languages to basically do the automation on AWS: C++, Go, Java, JavaScript, Kotlin, .NET, Node.js, PHP, Python, Ruby, Rust, Swift, SAP, ABAP. I'm not aware about these many languages even though. You can see JavaScript, you can build the environment using all these basically languages. You can use the Golang, right? You can use this Ruby to create these SDKs and you can able to access the things. Okay. And I'll show you all these ways as well. I'll tell you the things, how you can utilize these things. So I hope it is clear, guys. We have a three ways to control the AWS environment. Okay. And these are, see guys, just read these articles. These articles are very, very important. Just remember. If I will open this article, you will get the very good understanding here. You can able to see how you can create the accounts and all, how you can create the access keys and secret keys to get the programmable access. Okay. Using the AWS API, CLI SDK and all, right? So we need an access key and we need a secret key. AWS resource APIs, right? It can support these type of APIs for the communication purpose. Yeah, read through these articles. They will really help you a lot. Okay. You can use AWS CDK and all, right? This cloud development kit, AWS SAM, all these things. Just read it once. If you have a knowledge, which will really helps you. Now, guys, we have around 40 minutes more. So what I can do, let me just go through with the some of the basics about these AWS networking services. Okay, and after that, I'll just bind up your today's session. And from next class onward, it's all practical. Just remember, we will start like launching machines, BPC, and all. We are starting from the next class onward. So now, let me go down. So I have already covered this part, right? On-prem device, what we need, right? Everything. This also we have also discussed, right? Now, the first service which we wanted to understand with regards to AWS is known as AWS BPC. BPC stand for Virtual Private Cloud. And what happens basically? See, in your on-prem environment, right? We have these servers, right? These servers we will basically connect by using the either routers, switches, right, firewalls, right? These particular virtual machines, let's say we are running on whatever the hypervisor, right? So these particular routers, switches, everything comes under this BPC service only. Means BPC is a service which basically help us to create the private subnet, public subnet, internet gateways, net gateways, load balancer, all these things comes under IPsec site to site VPN, transit gateway, client to site VPN, everything comes under the BPC service only. And guys, for network engineer, this is the most used service, right? In BPCC, we can able to create the BPC. PPC is nothing, it's just a CIDR. It's just a CIDR means we will create a resource in this particular range only, means we have to define one CIDR range, just remember. Okay. Then we will create these subnets. You can think these subnets like a like a VLANs. We can create these route tables. These also comes under the BPC only. We can create internet gateway, egress only internet gateway, carrier gateway, DSCP options, elastic IPs, prefix list, endpoint service, net gateway, BPC peering connections, right? Your security, this network ACLs and your security group, DNS firewalls, right? DNS groups and all. Then your network firewalls. So we can also utilize this AWS network firewall. Policies, all these things like it will also support this TLS inspection related things. We can create this VPN related things, virtual private network, site to site VPN and all, client to site VPN, client VPN to endpoints, right? Then transit gateway, traffic mirroring, right? All these are the features of this particular BPC service only. So BPC is a very big service, and most of our discussion for this training is on we are going to perform with regards to this BPC service. Okay. So Amazon BPC is the networking layer of your Amazon EC2. Means whatever machines we will deploy using the EC2 service, and how now these machines will do the communication with the users is totally based or totally depends on the Amazon BPC, because Amazon BPC is just a networking layer which allows all type of networking related things. Okay, it allows you to build your own virtual network within an AWS region. You can control various aspects of your BPC, including selecting your own IP address range, creating your own subnets, configuring your own route tables, network gateways, and security settings, etc. You can create multiple BPCs within a region, means we can able to create multiple BPC, but there is a definitely there is a limit. I will go through with these quotas as and all, and we can increase these quotas as well, right? Each BPC is logically isolated even if it overlaps or shares IP address. And guys, just remember one thing. See, we have a BPC 1 and we have a BPC 2. Let's say these BPC I have on my Mumbai region. Then guys, whatever resource I will deploy on BPC1, let's say I have deployed this VM1 and I have deployed here on VM2. Now this VM1 and this VM2 is totally separate. Means let's suppose you have a two data center like a DC01 and DC02 in your on-prem environment. Until you will allow the communication between these DCs, they will not communicate. So BPC is like it basically like a data center. It's just a virtual data center over the AWS cloud. Okay. Your BPC can operate in dual stack mode, means you can use IPv4 based BPCs and IPv6 based BPCs as well. Okay. This means that resources in your BPC can communicate over IPv4, IPv6 or both. Because Amazon BPC is a double stack, however, IP4, IP6 operate independently. You will need to configure the routing and security component of your BPC for each address family. Just remember. AWS account have a default BPC. So guys, each and every AWS account, they will come with the default BPC. And they used to come with the default BPC. Why? Let me tell you. Let's suppose there's a person, he is a developer. He has a very good knowledge of Java language and Python language. Now, guys, this particular person wants to utilize the AWS cloud for developing some of the Java based application and some of the Python based application. And for that, he need one virtual machine. And he wants to launch this virtual machine on AWS cloud. Now, how he can basically do all these things? See, if he want to deploy this virtual machine, first he has to build the BPC environment, right? So guys, what AWS done, because he is a developer, he is not having good understanding of networking concepts, right? So what they have done, generally all the reasons they come up with the default BPC, which means that particular user, that developer, he don't needs to worry about creating any type of VPC related components. He can do one thing, he can directly launch the EC2 machine, or he can directly launch this VM and he can start using it. That is the main reason AWS comes up with one default BPC. So like AWS accounts have a default BPC created in each region with a default subnet created in each availability zone. The assigned CIDR block for of the BPC will be, and guys, you will get this particular BPC CIDR with the default BPC, which is 172.31.0.0/16, and IPv6 is not enabled on the default BPC. Just remember. Okay. And in BPC, we have a multiple components like subnets, route tables, IP address, security groups, network ACLs, internet gateway, net gateway, egress only, internet gateway, virtual private gateways, customer gateway, right? Then your BPC endpoint, BPC peering, placement groups, elastic network interface. See guys, this elastic network interface we will use. You have seen sometime like couple of bare metal devices or bare metal servers, what they will come with the two ports, right? You have seen they have a two NIC cards, right? So we will use this particular concept of elastic network interfaces, where we can basically assign these elastic network interfaces to our resources, so it can create two ports. Okay, two NIC cards, two virtual NIC cards, I can say. They have a DHCP option set, DNS is there, and BPC flocks, locks are there, right? So these are the couple of components which are available in your BPC. Then we have a elastic load balancer. So guys, I will not go in the depth of elastic load balancer. So in your AWS, we have a AWS managed ELVs. Means AWS has a Amazon managed elastic load balancers which we can use for the load balancing purpose. And we have a around layer 4 based load balancers and layer 7 based load balancer. Means we have a network load balancer NLB, and we have a application load balancer which is ALB. Okay. And AWS has around 4 types of load balancer: network load balancer, application load balancer. Then they have introduced, there is one more which is gateway load balancer. They have a classic load balancer, which is a very old version of load balancer. This is not used. Network and ALB, these are the ones which are used by the a lot. And they have a gateway load balancer, which is also used in some specific scenarios. And we will discuss that scenario even though we will perform these particular practicals as well. Okay. So they have this elastic load balancer service, right? I will not discuss much thing. Then they have a AWS Direct Connect. This is also a very good service. What AWS Direct Connect enables us, guys, tell me one thing. Let's suppose you have a two office. You have one office here in Delhi, and you have one office, let's suppose, in Bangalore location. Or let's take an example. You have one office in Dubai. Delhi is your headquarter, and Dubai is your branch office. 01. And guys, in Delhi office, what you have these particular 10 servers where you are running your application. These are the 10 servers available at your Delhi location. And on these servers, you are running your applications. Now guys, tell me one thing. Because you have started new office in Dubai location, so are you going to deploy these 10 servers into the Dubai location again? This is not the feasible solution, right? What we will do, we will make the connectivity between Delhi office and Dubai office. And guys, what are the ways to connect these particular offices? They can communicate securely. What? When anybody communicating, like any user who is in Dubai location, if he wants to access these particular servers, what? His data will go maintain the things, which is confidentiality, integrity, and authenticity. And also we will get the and there is a like high bandwidth we will get. What is the solution? What we can utilize here? I got the answer. We can use IPsec. IPsec is, you are correct. We can use the IPsec, but in IPsec, there's a latency, right? So we have an option called MPLS, right? So it is now applicable to the same thing. Now we have a concept of direct connect, okay? Direct connect is known as DX. Now, let's try to understand here. Let's suppose this particular servers we have into the AWS cloud. All these servers is a part of AWS cloud. And this Dubai is your on-prem environment. This is your on-prem data center where all your employees are working from office. Now, if you want to access these AWS resources, if you want to access these AWS resources from this office, and you want It can maintain the CIA and it can also maintain the high bandwidth. What you can do in that case, you can go with the direct connect concepts. We can use the IPsec as well, no doubt. We can use the IPsec, but here we will use the direct connect. Because in direct connect, it is just a point to point type of connection and we will get the high bandwidth. Okay. We will have a low latency when any user is accessing these servers. Okay. So that's the concept of direct connect. So AWS Direct Connect links your internal network to an AWS Direct Connect location over a standard Ethernet fiber optic cable. One end of the cable is connected to your router and the other to an AWS Direct Connect router. With this connection, you can create virtual interfaces directly to the public AWS service. For example, you can able to access S3 to the Amazon BPC. Bypassing internet services providers means ISP network we can bypass. What happens basically? See when you will basically get the direct connect, and we will do this direct connection between our on-prem data center and the AWS. What? So we have to purchase these connection from one of the some of the ISPs, right? They have a dedicated backbone connection between your data center and the AWS backbone. Okay. So we can utilize this direct connect service as well. Then we have a AWS Route 53. So Route 53 is a highly available and scalable intelligent DNS service. AWS Route 53 is intended for managing the DNS for the services and machines deployed on Amazon public cloud. The AWS Route 53 DNS service connects user requests to the ELB, load balancers, EC2 instance, Amazon S3 buckets, and other infrastructure running over the AWS, right? So if you will go here, let me just see if I have a diagram for this Route 53. So these are the like BPC example. I will cover them again, not any issues, but I have just taken. This is the example of load balancers, so not needed. This is the example of direct connect, right? In direct connect, what we are doing, we are connecting our on-prem environment with the AWS cloud through the MPLS type of connection. Okay. We have multiple use case for direct connect, multiple images are there, but I will not discuss right now. In AWS Route 53, it's like an intelligent DNS service. So what used to happen generally? Let me just draw one scenario here. Let's take an example. We have a, let's go like this. Let's take an example. We have these two regions. Okay. So these are the two regions we are having. One region is here and the region is here. Okay. Now, let's suppose this region, this particular region is the AWS Singapore region. And this is your AWS region in USA. Let's suppose it is North Virginia. Okay, now we have basically launched these three servers here. These are the three servers, server 01, 02, and 03. And we have put these servers behind this particular load balancer. Load balancer 1. Here also we have a same setup. We have these three servers. Server 0, server 2, server 1, server 2, and server 3. And we have a one load balancer. Now, this is the case, right? And here we have an internet. This is all internet. And these particular load balancers, they have a connectivity through this internet. via the internet gateway. Here also via the internet gateway. Now we have couple of users here in India, and we have couple of users in USA. Let's suppose these users are in California. Okay, now tell me one thing, guys. Let's suppose with these California users, what I have done, I have shared, if these users wants to access these servers, they can basically type a URL called load balancer 2 at the rate like SIANETS.com, load balancer to SIANETS.com. When they are basically opening this particular URL, they are basically accessing these servers. Now, due to some work, let's suppose this particular user is moved to India. And when this user moved to India, and if he wants to access the servers, he is just typing lv2.sianets.com, and what his traffic is going till this particular North Virginia region. So guys, what will happen if he will access the servers like this? Delay, right? He may experience some type of latency, some type of delay will be there. So what happens if we have some type of solution where, let's suppose we have one global URL which is lv.sianets.com. If somebody is typing this URL, and if that user is in Asia region, then his request will go to these servers. If this particular user is in USA region, then his request go to these particular servers. Then in these type of scenarios, your Route 53 going to help you. What we can do, we can basically see Route 53 is a global service. So let's suppose we have this Route 53 service here over the AWS. In Route 53, what it is, a intelligence DNS. We can able to configure the routing on Route 53 on the basis of locations. Means if user is coming from Asia, he will basically get the IP address of this load balancer. And if the user coming from USA, he will get the IP address of this load balancer. So it is similar to like a global traffic manager like GTM. Okay, so this is the use of your Route 53 service in your AWS. I'm just giving this basic understanding of them, guys. When we will perform these practicals, we will do such type of labs. It's not like that. Whatever I'm saying, I will perform these scenarios as well. Okay, because of that reason only, if you will see, I have basically purchased this particular Route 53 domain and all actually. If I'll go into this Route 53 DNS, see, this is the domain which I have purchased already. This bdo-cnets.com. This domain I will use. This is a globally unique domain actually. Okay. So we will do all these labs when we will discuss this thing. Then we have a AWS CloudFront. Amazon CloudFront is a web service that speeds up the distribution of your static and dynamic web content such as .html, .css, .js, and image files to your users. CloudFront delivers your content through a worldwide network of data centers called edge locations. When a user requests content that you are serving with the CloudFront, the request is routed to the edge location that provides the lowest latency, which is time delay, so that content is delivered with the best possible performance. We will discuss this CloudFront related practicals as well, don't worry. Okay, then we have a AWS web. The AWS WAF is a cloud-based solution that helps us to prevent the layer 7 attack. Guys, what is the main use of WAF? WAF stands for Web Application Firewall. Like we have a F5 ZTM. Sorry, we have a F5 WAF or ASM. What it used to do, see, this WEF devices, what they used to do, they used to basically prevent us from the parameter tampering attacks. Cross site scripting attack means, see, my if I have a firewall, let's suppose Palo Alto, maybe this firewall, it can check the layer 7 content, but it will check the malicious content at layer 7, right? If somebody is modifying the parameter, means he is just modifying your HTTP header, something inside your HTTP header. These type of attacks, my firewall is not able to detect. So such type of attack is detected by the web solution. So we will discuss this AWS Web as well. So like AWS Web Application Firewall is a security tool that helps you to protect the application against a web attack. And guys, if possible, I will try to launch these attacks. If I will found if I will found any type of like any type of vulnerability application, then I will install that application on one of the Linux machine and we can test it out there. Web monitors and controls unusual bot traffic, blocks common attacks patterns such as SQL injection or cross-site scripting attacks. It is also lets you monitor the HTTP and HTTP requests that are forwarded to an Amazon API gateway, Amazon CloudFront, or or your application load balancer, right? Then we have a one more AWS service which is known as AWS Shield. AWS Shield Standard and AWS Shield Advanced provide protection against denial of service attack. So guys, we have a DOS attack, right? So if you want to protect from DOS attack, you have to use the feature called AWS Shield. Right? DOS attack for the AWS resource set at network and transport layer and the application layer. So guys, I can launch these DOS attack as well. I know everything how to launch these attacks and all. Okay, that DOS attack is an attack in which multiple compromised system try to flood a target with the traffic. A DOS attack can prevent legitimate end users from accessing the target service and can cause the target to crash due to the overwhelming traffic. So we will launch these attacks and we will see the things practically. AWS Shields provide protection against a wide range of known DOS attacks, vectors, and zero-day attack vectors. Shields detection and mitigation is designed to provide coverage against the threats, even if they are not explicitly known to the service at the time of detection, right? So we can get that protection from the volumetric related DOS attack. Like I can send lots of data, which is like SYN flood, TCP, SYN flood, UDP flood, ICMP flood, or other IP flood type of attacks I can launch easily, right? Network protocol related floods, right? TCP floods, all these attacks I can launch, right? Application gateway attacks, we can flood the application with the help of with by sending lots of HTTP like requests at the application level and all, right? Like UDP reflection attack, TCP SYN flood, DNS query flood, all these attacks. Okay, so these are the couple of features. So we have a AWS Shield Standard. AWS Shield Standard is free and it offers DOS protection against some of the more common layer 3 DOS attacks. Okay, layer 3, layer 4, and transport layer DOS attack. This protection is applied automatically and transparently to your elastic load balancers, Amazon CloudFront distribution, and Amazon Route 53. AWS Shield Advanced. This is a paid service. For AWS Advanced, we have to pay the service, pay the amount for this service. AWS paid. This is paid service provides additional DOS mitigation capabilities, intelligence attack detection, and mitigation against attacks at the application like the AWS web included or the network layers. Shield Advance also provide additional detection and mitigation against large and sophisticated DOS attacks and near real-time visibility into the attack. Means we will get the logs as well if there is any type of attack is going on. Then we have a AWS guard duty. So we will also see this particular feature. Like this service allow customer to analyze AWS Cloud Trail events, PPC flow logs, DNS logs to look for unusual or unexpected behavior in their AWS account. Means it is just a log analysis service on the AWS. It then compares the log data to numerous security and threat detection feeds, searching for anomalies and known harmful source such as IP address and URLs, right? So we will also configure this thing, this particular feature, AWS guard duty. Okay, so guys, these are the main things which I wanted to cover with regards to today's session. Let me just see if I have anything else. And after that, I'll just bind up the session. So I have just provided the overview of the AWS infrastructure reasons, right? What are the service, what are the main service which is offered by the AWS, right? Now, from next class onward, we will basically jump towards the practicals, create BPCs, launch EC2 machines, right? All these type of tasks. Okay. Let me just see if I have anything else. Things are good now. Okay. So we have discussed this introduction, history, infrastructure where region, availability zone, local zones, edge location, POPs, outpost, wavelength, how to choose region. This also. Okay, so I think we have discussed whatever I have mentioned for today's session. Okay, so we are, I think, good to wrap up this session. So let me stop the recording now.